Hello students, welcome back to the lecture series of software engineering course. Today I will tell you one of the software metrics form as complexity of the software. So to calculate the complexity of the software, we do have two popular methodology. The one is Halstead software complexity and the another one is cyclometric complexity. I will cover cyclometric complexity in my coming videos, but today I will cover Halstead software analysis or Halstead software complexity. So as I have written over here, in 1997, Morris Howard Halstead has introduced this Halstead software metrics to actually measure the complexity of the software. So according to Halstead, Halstead states that a computer program is an implementation of an algorithm considered to be a collection of tokens, and these tokens can be operators and operands. So to calculate any program's complexity, we should know about, because program is composed of these tokens, that is operators and operands, and you well know about what are the operators and what are the operands. So Halstead tells us any program can be identified by these operators and operands. So if I need to calculate the complexity of the program or of the software, then I should know about about the operators and the operands. So it actually checks the complexity of any program by some indicators. N1, that is a variable which it states that there are number of unique operators in the application or the program. N2 is number of unique operands. Capital N1 are the number of total occurrence of the operators, and N2 is the total number of occurrence of the operands on that code or on that source code or the program. So to calculate, we do have some metric reports. So here we do have vocabulary of the program, size of the program, or you can say length of the program, volume of the program, difficulty level of the program, efforts taken by in any program, errors, the possibility of errors in any program, and the testing time required for any program. So to estimation of these metrics, we do have several formulas, which is actually calculated on the basis of these four things, which we will get it from any software code. So for vocabulary, we do have the sum of this number of unique operators and operands. For calculating the size, we should know the total number of occurrence of the operators plus the total number of occurrence of the operands. For volume, we should have the size into log 2 of the vocabulary, which can be written as n into log 2 of n, as simple as that. When I calculate the vocabulary and size, then it can be calculated volume in this way. Difficulty, that is n1, number of operators upon 2 into n1, that is number of occurrence of the operators upon number of operands. Efforts, that is difficulty into volume. Errors, that is efforts upon 3000. Testing time, that is efforts upon s, and s as the 18 seconds is given. So by these calculation, we can easily estimate the software metrics in terms of the complexity of the software. So we calculate this complexity on the basis of the tokens given in any program. These tokens can be the operators and can be the operands. So this is very simple to calculate the complexity of the software program. So let me give you an example of this Halstead software complexity. As you can see the example, I'm considering a program, a source code, which is actually some program of swapping, right? So we don't need to consider what is actually the logic behind this program. Our aim is only to calculate the complexity of this source code. So according to Halstead, we should have four important indicators. One is number of operators, number of operands, the total occurrences of the operators, and total occurrences of the operands. So it means that I need to calculate N1, N2, capital N1, capital N2, right? So firstly, I will calculate the number of operators. So as you can see, the number of operators we could have, the first one is I, J, P, N, A, 1, 2, 0. So as you can see, the number of operators we could have 8, right? And if I calculate the number of operands, then you can see open bracket 1, the multiplication sign 2, comma 3, close bracket 4, open curly 5, comma is over, semicolon 6, less than 7, equal to 8, minus 9, plus 10, plus 11, greater than 12, square bracket 13, close bracket 14 of curly, and int 15, if 16, for 17. So you can easily calculate N2 as 17. Now if I need to calculate the N1, that is the number of occurrences of the operator. So if I calculate I, so how many I comes times 1, 2, 3, 4, 5, 6, 7, 8. 8 times I comes. How many times J comes? 1, 2, 3, 4, 5, 6, 7. J comes 7 times. How many times T comes? 1, 2. How many times N comes? 1, 2, 3. 3 times N comes. If I won't count the function name, then only. How many times A comes? 1, 2, 3, 4, 5, 6. 6 times A comes. How many times 1 comes? 1, 2. 2 times. How many times 2 comes? 1. How many times 0 comes? 1. So if I calculate the total, 8, 7 is 15, 16, 17, 18, 19, 20, 26, 27, 28, 29, 30. So we can easily count the value of N1 as 30. Same happens, we need to count the value of N2, that is total number of occurrences of N2. So I need to count how many times star comes, how many times open bracket comes. So by that simply calculation, if I get total number of operators, total number of operands, total number of occurrence of the operators, total number of occurrence of the operands, obviously the rest of the metrics easily can be calculated because there is no rocket science in this calculation. That are simple arithmetic calculation. The important factor of calculating Halstead complexity is that we need to be very careful once the source code is given to you. Once only the value is given to you as N1, N2, capital N1 and capital N2, we don't need to be bothered about these calculations, right? Only we need to be very careful once the source code is given and we need to calculate the number of operators, the number of operands. Then at the time of counting, we need to be very careful. Rest of the calculation of the metrics are very easy, that can be easily calculated. One problem would occur once you will calculate the log base 2 of vocabulary by the simple calculator or the calculator given in the mobile phones. Then as simple as that, you will calculate this as log 2 vocabulary basically equal to V is equal to N into log N upon log 2. As simple as that. So I hope the calculations of software metrics by using Halstead analysis is not that complex. So we will discuss in the next video about the cyclomatic complexity, which is also one of the very interesting software metrics to calculate the complexity of a software program. So I'm ending over here. Thank you, students. Keep watching and listening.